So hey everyone, we were in the video series of the database for system design, and today we will be talking about types of database. Okay, so there are mainly two kinds of database, which is SQL and other is NoSQL. And further, if you divide NoSQL, there are many other types of database for which all might not be here, but the major of them are here, which is document, key value, graph, and column family database. Okay, now let's see all of them one by one. So I would like to start with a relational database. So what actually is a relational database? So a relational database stores data in table in the form of rows and columns. Okay, for an example, this is how the relational database stores data in the table. Okay, and we can see the rows here, row 1, row 2, and row 3, and the column are defined as ID, name, and email. Okay, now if I take another piece of data, again stored in a table, we can see the relationship between these two tables, right? So what is the relationship? So the interview table is holding the interview for each of the users, right? So users and interview have one-to-many relationship, as we have discussed earlier, right? Because each user have many of the interviews, right? So each user can have many of the interviews, but one particular interview doesn't belong to many users, right? For example, you gave an interview for Django developer. Does that particular interview belong to any other user? Of course, they might have given the interview for the Django developer, but the particular interview that you have given doesn't belong to any other user, right? So that's why they have one to many relationship, that is one to n relationship, right? So because they have relationship and they are related to each other, so that's why we refer relational database as relational. Okay, talking about the language used by relational database uses SQL language, which is structured query language, which something looks like this. Select all from interviews where user ID equals to 1. This is just saying that give all the interviews to me where you see user ID equals to 1. Okay, now it's not enough for us to just learn about relational database. We also have to see its use case. So let's see where are relational database useful. Okay, so the sectors could be banking, e-commerce, payroll, accounting, payments, and etc. Okay, and things like transaction data integrity and relationship highly matter in this kind of sectors. So we use relational database in the following sectors. So I think that might have been clear for you. So we have successfully completed the left branch of the database family. So now let's jump into NoSQL database. Okay, so NoSQL database is a non-relational database system designed to handle unstructured, semi-structured, and even structured data. Okay, don't miss this out. It also stores the structured data. Many people mainly refer that NoSQL database is mainly designed for unstructured and semi-structured, but they usually miss out the structured part. Okay, so you have to be aware here. Now, non-relational or NoSQL database is further classified into document database. Now, let's quickly see what document database actually is. So, in case of relational or SQL database, we used to store data in the form of row and column in the table, right? But in case of document database, which is a type of NoSQL database, we store data in the form of document. So, we store each record as a document. Now, let's quickly observe how the records are actually stored. So this is how the data are stored in document database. Okay, it somehow looks similar to JSON format where we define data by using key value pairs like ID and value is 101, name, Sandesh, email, and sandesh@example.com, skills. So overall, a document database is a database that stores data as documents commonly represented using JSON-like structure rather than rows in a relational tables, right? So a popular example for document database is MongoDB. Okay. Now let's see a better use case for a document database. So when do we actually need, in what case scenarios we actually need a document database? Okay, so imagine a user. If we take user A and the information for user A is stored like this in a particular document, and we have another user, okay, user B. If you look at the skill section of user A, that is Alice, he have only 2 skills, right? But if we look at the user's skill section of user B, he have more skills than Alice. We are actually seeing the variation in data, right? And the most popular use case for the document database is in the case of variation, which we are seeing right here. If we have to store the same kind of data in SQL database or relational database, we have to separately create a table and we have to separately define a foreign key relationship in a SQL database. But in case of document database, it is so easy for us to store the skill for user A and user B, right? So the document database is very useful for the cases when the data are flexible, as we have already discussed here in case of skill, and also when the data are independent, which means that adding or removing any kind of key value pair in the data set doesn't affect the application. Okay, for example, in case of user A also has hobbies. Okay, there are list of hobby for user A, but in case of user B, let's say user B doesn't have any kind of hobby, he can just ignore it and let it be as it is. Okay, so if he doesn't want to store hobbies, so doing that is also totally fine for the case of document databases. So we say that when the data are independent, we use document database oftenly. Now we are done with document database. Now let's jump into key value database. Okay, simply we store data in the form of key value pair in key value database. Okay, something like user 100, which is a key. The value for user 100 is Sandesh, and or the name of the user 100, and the name of the user 100 and the name of the user 100 is Sandesh. Or or a or we can also store session, the information regarding the session of the user, that is user is 100, or we can also store the items in the cart. Okay, and the value for this is suppose egg, butter, and so on. Okay, so this is how we store data in a key value database. And in case of retrieval of data in key value database, we simply use the key to retrieve the data. Okay, there's some method like get, and you place the key right here, user 100, and this here is the name of the user for you. Okay, which is Sandesh. So this was a simple mechanism of key value database. So a very famous example for key value database is Redis. So the key value database is mainly useful for the things like caching, session, and setting up rate limit, or storing some temporary data for a short period of time, and fast lookups. Okay, and most of the things that I said is done by Redis. So Redis is useful for caching, storing sessions, rate limiting, fast lookups, and so on. Now that was all about the key value database. Now let's jump into graph database. Okay. Now a graph database is a database that represents information as a nodes and relationship as edges. Okay, and making it efficient to traverse highly connected data. For an example, let's take a social media network. Let me draw some nodes. Let's connect all of them with edges. For example, this is a network of friends in a Facebook. Okay, and Alice is a friend of Bob. Bob is also friend of Charlie, and Bob is also friend of Emma. Okay, now if we store this kind of data in a graph database, it would be easy for us to traverse the data like friends of friends, followers of followers, because each node are connected with one another. Now if we have to find the friend of Bob without looking at the actual data of Bob, by only looking at the data of Alice, let's see, suppose this is Alice. Okay, and Alice has friends, it includes Bob as well, and there are some other friends of Alice as well. And inside the friend list of Alice, we get Bob as a friend. And if we look into the friend list of Bob, we will get all the friend of Bob, including Emma. So in the cases like this, graph database is very much useful. So that was simply about the graph database. And now let's jump into column family database. So talking about column family database, instead of storing them as row and column or any kind of document in case of NoSQL database, or any kind of network in case of graph database, this column family database stores in the form of category the data holds. For an example, if we have data about a person which holds things like name, okay, and email, purchase, order count. So here are all the data of a particular person. Okay, now if we have to again categorize this all the data, I would do it like this. First of all, I would categorize this name and email as personal detail. Okay, and I would classify this purchase and order count as purchase history. Okay, and now this personal detail and purchase history becomes our family name. Okay, so for our first family name, we also call it as column family personal detail. The data is stored as follows. For this ID, we have name, for example, Alice. Okay, we store name and email right here. Let's also store one more data. So this was for our column family personal detail. Now let's also make the purchase history column family. Now I'm not going to store the purchase history for the person named Bob, okay? Because Bob hasn't purchased anything yet. So if Bob doesn't purchase anything, storing or creating one more row for the Bob which doesn't have any value like SQL database is waste of memory, right? So that's why in this type of cases we use column family database, and this also makes the efficient use of memory. And popular example for the column family database is Apache, Cassandra, and HBase. Okay, you can simply explore all of them. You'll find the similar structure of data storage. And with that, we have covered the major database types we need to cover for system design, which are relational, document, key value, column family, and graph database. Okay, so each one is designed around a different way of storing and accessing data. So the important thing is to remember that we don't choose a database just because it's popular. Okay, we choose it based on the data model, access patterns, consistency requirements, scale, and workload of our system.